Tutor, where school is made simple. Let's go. Over the years, many students have reported that they like geometry better than other mathematics because it's easier for them to see things. And one of the things we're going to look at today is the area of a triangle and how we come up with it. We've learned for years that the area of a triangle is 1/2 base times height. But where did this come from? How did they figure this out? And it may shock you to see a rectangle on the screen and to know that the area of a triangle comes directly from the area of a rectangle. But let's take a look at this. I'm going to start by picking a point E somewhere along the top edge of my rectangle. And then I'm going to form triangles by connecting point E to the lower vertices of my rectangle, points D and G, like such. And then I can identify 3 triangles within my rectangle. And I'm going to label these triangle 1, triangle 2, and triangle 3. I can say that triangle 1 plus triangle 2 plus triangle 3 is going to be the rectangle. And now I want to see if there's anything I can do to take this further. And one of the things I'm going to do is to use a concept called rotation. And these are part of what's known as transformations in geometry. First, I'm going to start by taking the midpoints of my segments, and then I'm going to mark them as the center and then rotate triangle 1 around this point. And I'm going to ask it to rotate it 180 degrees. And now when I do that, I can see that triangle 1 is now rotated inside of triangle 3. Now I can do the same thing with triangle 2. And I'm going to rotate 180 degrees around the midpoint. And now notice that triangle 1 plus triangle 2 equals triangle 3. Let's see if we can work this out with numbers and see if it makes sense. So let's look at this. Here are the areas of my triangles. Now let's look at the area of triangle 1 plus the area of triangle 2. And I find out that it is 58.69 square centimeters, which is exactly what the area of triangle 3 is. Now, let's take this, now that we have a little bit more information, we know that, again, the area of triangle 1 plus the area of triangle 2 plus the area of triangle 3 is going to be equal to the area of my original rectangle. Let's see, is there anything else we know? Well, we know that the area of triangle 1 plus the area of triangle 2 is equal to the area of triangle 3. Now, we can do some substitution. Since triangle 1 plus triangle 2 equals triangle 3, then we can replace triangle 1 and triangle 2 here with triangle 3. The algebraic concept of substitution. Now that I have that, okay, triangle 3 plus triangle 3, well, that's like saying x plus x, which will simply be 2x, or 2 times triangle 3 will equal to the area of the rectangle. Well, there, 2 times anything, if I'm solving it using the concept of literal equations from Algebra 1, this would be a one-step literal equation. How do I cancel multiplication? Well, I cancel that out with division. So if I divide by 2 on both sides, I get the area of triangle 3 on the left, and on the right, I have the area of the rectangle divided by 2. Now we come back to the concept of what the area of a rectangle is. And we know that it's going to be base times height. So we can substitute one last time and say the area of triangle 3 is going to be equal to base times height divided by 2. Let's see if we can confirm that with our diagram. Well, the area of the rectangle is 117.38. Well, 1/2 the area of the rectangle would be 58.69. So we have confirmed that the area of the triangle is 1/2 base times height. Now, looking at this on your sheet of paper, you can simply pick this point E and put it inside anywhere along the top edge of your sheet of paper. Draw the lines from point E to your corners and then cut along these lines. And then if you simply rotate this triangle 180 degrees, it will fall directly inside the base triangle. And same thing with this one. I encourage you to try this on your own. I try this many times in my class, and the students are absolutely amazed to see this transform right in front of them using their own hands.